All right, we're back now talking more quadratics. All right, and let's resume with the next slide from our presentation. So now we're talking about converting from the standard form to the vertex form, which is going to be done via, completing the square. So here's your standard form of the vertex of, the quadratic function. We want to start by completing the square. Completing the square requires that the coefficient of the leadoff term be positive 1. It is not. It does not say we cannot do it. It simply means we have to factor that out. So we factor out the negative 1/2. Be mindful that the new coefficient of the x variable will be minus 8. After all, if you distribute that, you will get back to the original expression. Okay, now we are tasked with having to complete the square. Completing the square, of course, calls for adding 1/2 the middle coefficient, okay, which of course would be 1/2 of 8, which is 4, and then squaring it, which is 16. Now, here's the thing. That 16 there is in red because it's disrupting the balance of the function. And effectively, it's not 16 by which the function is offset. Okay, it's 16 times the negative 1/2, which is actually negative 8. So this function, the difference between this line and the previous line is that this is, 8 less than that. Okay, so it's offset by negative 8, which means we need to bring it back in balance by adding 8. Okay, so if we add 8, we'll keep it in balance. Okay, so that's why I say here we add 8 because we effectively subtracted 8. You say 16. Now it's 16 times negative 1/2, so the offset is by negative 8. Bring it back in the check with a positive 8. Okay, so now we're just going to factor this so we can identify the HK. HK is 4, 5. So we have our vertex at 4, 5. We're opening downward from the original expression that is in the standard form. We know the y-intercept right up here. It's negative 3. The axis of symmetry is x equals 4. So 4 units to the right of the axis of symmetry is our image point at 8, negative 3. So put it all together, and here we go. Okay, we're at a 4, 5 as our vertex. We're at negative 3 as our y-intercept, and we're at 8, negative 3 as the image point of that. We're opening downward because our leadoff term was negative. Okay, let's convert the other way. Or let's do it in general, let's say. So the general expression is ax squared plus bx plus c. All right, again, following the lead of the previous problem, we need to pull out the coefficient of a, coefficient of x, which is a. Okay, so there you have it, which means our new coefficient of x is b over a. You check that. A x squared, a times b over ax gives you bx. Okay, so now we have to complete the square. It would be half of the x coefficient, which would be half of b over a, which would be b over 2a. Okay, it needs to be squared. Okay, half of the middle coefficient squared, and trying to keep the balance. Okay, so here it is in red. Okay, the b over 2a is squared. All right, but now let's remember, when that b over 2a is squared, it's offsetting the balance, not by that much, b over 2a squared, but by that much times a. Okay, by that much times a. So then we have to offset that by subtracting it right away, okay, from the c term over here. All right, you would be best if you would just run through this exercise on your own. Okay, and then it would make sense to you. Okay, so here it is we're gonna factor this as x plus b over 2a, and we're going to, okay, as you see down here with the a pulled out, and then we have this expression down here, all right, which we're going to clean up a little bit by, we saw that we get from the previous line to that by squaring, which is b squared over 4a squared, and then we're going to have that a, which is going to cancel out, so we have b squared minus 4a. So the thing about doing it in the general sense, which is very helpful, is that it identifies for you immediately, okay, in terms of A, B, and C, what's the vertex, okay? So the vertex is simply the opposite of B over 2A, all right, because mainly we want in the vertex form this to read x minus h, the quantity squared, plus k. So our h term is the opposite of b over 2a, okay? And then the k term is this grouping over here, okay? So the vertex is, come back, the vertex is negative b over 2a, and then this term, which is effectively just, you know, the function evaluated. That, so let's say our h value of the vertex was 2. Then the y value of the vertex would simply be by throwing 2 in for x, evaluating the function at 2. So I always say the vertex is negative b over 2a, comma, f of negative b over 2a. And that finds it real quickly for you. We could go back into the previous problem, okay, and check that, and maybe we should. We'll do that to end this video. So here's our original problem. A, negative 1/2, B is 4, C is negative 3. So we're saying, okay, the x-coordinate of vertex is negative b over 2a. So b is 4, we have the opposite, so that's 2 over 2 times, sorry about that, okay. So we want negative b over 2a, which is going to be negative 4 over 2 times negative 1/2. So that's going to be negative 4 over negative 1, which is going to be positive 4, okay? And that proves to be our vertex there. And if we throw 4 in, we'll get out the y coordinate of the vertex. So throwing in 4 squared is, of course, 16 times negative 1/2 is negative 8. Keeps jumping ahead. I'm sorry about that. And you could do the calculations and see that f of 4 would give you that value of 5. Okay, we're going to stop it here and resume in the next video.